Okay, hello and welcome to another section in further mathematics. In this section we'll be talking about correlation and regression. Now when you talk about correlation, if I said what is a correlation between two variables or two things, like if I say what's the relationship between you and your parent, you tell me one, you happen to be their child and they happen to be your parent. That's number one. Number two, you're from the same village. Number three, your age will increase as their age also increase. You can never be as old as your dad till the day he dies. You can never be as old as your mom until the day she also dies. So as your age increases and your mom's age increases, your age can never be equal. You can never be 5 years today and your mom 30 years, and tomorrow you expect a situation whereby you see yourself in 30 years and maybe 60 years and your mom the same 60 years with you. It's not possible because it's not reversible. So there are some things that correlation talks about, the relationship between variables in mathematics. So for example, one thing I want us to do about correlation and regression line is that it's just a chart that shows the relationship, how the relationship between two variables is. For example, if we have y, this is the y-axis and this is the x-axis. If this is our point y and this is our point x, now let's call it s. If y increase when s increase and y decreases when x decreases, the scattered diagram, their relationship would look like this. This is the nature of their relationship. If you plot their relationship on a graph, it will look like this: a straight line from the origin. This is the origin, the 0 mark. This is to show that the value of x keep increasing. The value of y increases as that of s increases. So you have a curve with a straight line like this. That will be the nature. That's because as this one is increasing, this one is also increasing. But if you're in a situation whereby you have an inverse relationship, this one is known as a positive relationship. They both increase and decrease at the same time. But if this is our value of y and this is our value of x, and the graph, if y increases when x decreases, or when x increases, the y increases. Okay, let me say for example, I know the example is very funny. You know, the more you get older, the more you get closer to your grave. Let me say for example, let y represent your age today, and let x represent the day you will die, or the person will die, not you. You're not dying. Hey, never mind. The person will die. Now, for example, if the person have 100 years to stay on earth, if the person's age today is let me say 20, the number of age left for him to stay on earth is 80 years. 80. If the person gets to 40, the number of age left for this person to stay on earth is how many years? Is 60. Now, if the person gets to 50 years, the number of age left for that person to live is 50 years. If that person gets to 70 years, the number of age left for that person to stay on earth before he dies is 30. And if the person gets to 90 years, the person has just 10 years to stay on earth. If that person gets to 99 years, you know what it means. He has only 1 year to stay on earth. Now look at the relationship. If you look at, if you watch what is going on, the value of y was increasing 20, 40, 50, 70, 90, 99. The value of y is increasing. But look at what happens to the value of x. S was rather decreasing. 80, 60. It was going down. 50, 30, 10, 1 until you even get to 0 where the person will die. Now you see from this relationship, you discover that y is increasing when X was decreasing, was going down. And if X start increasing, then Y will also decrease. Now, if you plot this on a graph, on a scatter diagram, your graph will look like this. This will be in the nature of the graph. And you have something like this. Now you've seen what we are having. When the both was increasing together, the graph was like this. Now, if this one is increasing while this one is decreasing, your graph will go this way. This will be the value of the graph. It will no longer, this shows a negative. This is a form of negative relationship. This is a negative relationship. But most times it might not be relationship. If I now tell you, plot a graph of the time, the relationship of when you eat each day, plot it in respect to the time that okay, the number of time that your food used in preparing the food. You can see that the first day, let's say X signifies time, Y signifies the time you spend in eating your food. You can see that the first day they might spend 2 minutes in cooking, while you that is eating, you might use 4 minutes in finishing the food. Another time, based on your mood, they might decide to use as large as 10 minutes in cooking, and the sweetness of the food can even make you to use 2 minutes to eat, to finish the food. So you see, everything will just be scattered like this. No uniformity, scattered. Some will go like this. So this shows zero relationship. This one shows a form of zero relationship. No relationship. It doesn't show if Y is increasing, X is increasing, or X is increasing and Y is increasing. This is a form of zero relationship between the variables. But some cases, you might see that at the beginning, the relationship might be negative. At a certain point in time, the relationship might end up being positive. So in a graph like that, you can see a form of this nature. At first, what you experience is what? Is a kind of negative relationship. When you get to this point, you start experiencing a positive relationship. This one will now go this way. Now, this is your Y, and this is your X axis. Now, in this case, you saw that at first it was a negative relationship, which signifies this negative coming down. At this point, getting to this point, he started experiencing a positive relationship. This showed that it is a non-linear relationship between X and point Y. So this is how the correlationship graph goes. This shows the relationship between point X and point Y at every given point in time. So if they are related, just know that this will be the nature of your graph. If they are related but in a negative, in an inverse way, whereby one is increasing, one is decreasing, you see a graph like this. If they are not related, you see a scattered graph like this. But if it is a non-linear relationship whereby at a certain point the value increase, when it gets to a point the value starts decreasing, then you start having something of this nature. So I think with this is a very wonderful and a detailed explanation of what we need to see with when it comes to correlation and regression. I would like to say a very big thank you for joining us in this lesson. But in order for you to refresh your memory on what we've just discussed, please take the test that will appear on the screen shortly. Do well to use the lesson notes on the platform for better information on the topic we've discussed. Feel free to drop your comments and your questions on the comment section. We'll be glad to hear from you. Thank you.